All right, so you already did sine, cosine, and tangent, and now you have to do their reciprocals. And so you've got three reciprocals, one that goes with each. So the first one that we want to look at is we call cosecant of theta. And so cosecant, you just abbreviate CSC. You don't want to write down the whole thing. All of our trig functions only have 3 letters. And that is going to be the reciprocal of sine. Right. And so that's just your notation for reciprocals. You don't actually create 1 divided by something. That's just how you say I want to write the reciprocal. So once you find sine, you're just going to flip the fraction to get cosecant. Right? That's the same thing as if I have sine is the same thing as the reciprocal of cosecant. So those two go together. Like once you have one as a ratio, flip the ratio and you get the other one. All right? So typically when we're doing our trig, we really focus on sine, cosine, tangent, so that way we can just flip the other 3 over and get them easier. All right, then you also have your secant of theta. And secant of theta is the reciprocal of cosine. And so one thing you got to remember is that when you're finding your reciprocals, the first letter never matches. All right, so for secant to be the flip of cosine, cosine is the reciprocal of secant. So you can see like they just don't match. So if you're ever trying to figure it out and you're writing a reciprocal where the first letters match, you've done something wrong. Right? And then your other reciprocal is cotangent, and that's the reciprocal of tangent. Right? And so again, if I know tangent, I can flip that to get cotangent. There is a lot of other higher level trig that you don't need to know right now in terms of like where these come from and why their names are those names and all that. Don't worry about it, right? You just need to know the 3-letter abbreviation and which one is the reciprocal of which. All right, so we want to use the reciprocal properties to evaluate. Right, and so we're not going to like really, we're just going to set up, kind of like how before we just set up the sine, cosine, tangent if you know the sides of a triangle. That's what we're going to do. So for your first little example, you just want to draw a triangle. And I'm going to label one side or one angle theta and the other one beta. All right, so I'm going to use those little Greek symbols, and then I'll give you all the different sides so you don't have to worry about the Pythagorean theorem. It's just going to be given to you. So if you're missing a side, you've got to use the Pythagorean identities first before you move on. And so I want to find all 6 trig functions. So I want to find the sine of theta, cosine, and tangent. And then since I want to find their reciprocals, I'm going to write their reciprocals to the right of the one that they kind of connect with. And so the reason why I like doing it in that specific order is so that way if I find the first 3 off to the right, I can just flip the fractions for the one that's to the left. All right, so you want to kind of keep the reciprocal properties or the reciprocal trig functions like directly next to the ones that are like their counterparts. All right. So it's really important you know that you're talking about theta. All right. So sine is going to be 12 over 13. All right. Cosine is 5 over 13. And tangent is 12 over 5. And so you want to be able to make those like super fast. You don't want to be stuck on sine, cosine, tangent when you're already given the triangle. And then that way when you go and you have to find the other 3 trig functions, you can just flip the fractions. Right? Whatever is to the left is its counterpart or its reciprocal, and I can just flip those. Right? So there are relationships in terms of like cosecant being hypotenuse over opposite, but we're not going to try to go backwards and try to remember like how to, what those are in terms of the sides. We really just want to look at sine, cosine, tangent, and then just flip them. Right? That way you don't have to worry about that. If you look in like some other trig books or some different videos, they'll actually go through like that cosecant is hypotenuse over opposite and secant hypotenuse over adjacent. Like they'll give you those ratios. I don't really care about that. I just care about finding these three and then flipping them. All right, and that's it. You can answer questions about beta. So like if I just gave you a random one and said, what is the tangent of beta? All right, so now you just have to know, looking at beta, now your adjacent and opposite sides are going to change. And so that's going to be 5 over 12. If I just, like, just throw out random ones, because some of your assignments, like one of your quizzes, is just going to be random trig. It's going to be like, here's a triangle, look at beta, and then find the cosine of beta. And then you're going to get like crazy ones, and I'll just be like, all right, what's the cosecant of beta then? And all of a sudden you'll be like, I don't know. All right? Because your brain doesn't work. Typically, when you're dealing with SOHCAHTOA, that's not one of your 3 trig functions. So this is, if you just got this random one and you're like, I don't know, beats me, you're not going to want to skip it and take the L. All right? You need to know that this right here is the reciprocal of sine. So you want to first just look at the triangle and say, what is the sine of beta? All right? Because that's the easy one when you're dealing with SOHCAHTOA. And so if your sine of beta is 5 over 13, then you can actually answer that question that then cosecant of beta is just the flip or the reciprocal. And so you want to be able to know the reciprocal properties. So if you're asked about any of those like cosecant, secant, cotangents, look at the reciprocal one and then just flip that ratio. And it makes things a lot easier on you. All right, so I'm going to give you one more triangle for this. All right. I'll just call them ABC. All right, you don't have to use Greek letters. All right, so don't get stuck. I'm going to toggle back and forth between Greek letters and alphabet. All right. And so I'm going to give you the triangle, and I'm just going to tell you I want you to use trig ratios. And I want to find angle C and angle A. And I want you to use trig. We want to use trig functions for both of them. Right? I don't want to use like just subtracting from 180. So I want to be able to see it. All right, so for angle C, I don't really have to do a whole lot in terms of, like, I don't have to do anything extra for this. So for angle C, I'd have to look at the sides that I have. And so I have an adjacent and a hypotenuse. And so that's going to be my cosine. All right, so again, I am going to be expecting to see that setup. And then to find C in my calculator, I'm going to do that cosine inverse of that ratio. All right. Again, if you want to use the classroom calculators, that's fine. I mean, I know money's not always, right after Christmas, sometimes you don't have a whole lot. But if your parents can just go get you an $8 or $10 calculator, it'd be so much easier to be able to just plug it in exactly the way you see it. All right? It'd be so much easier that way. So that angle C is about 73.74 degrees. And I'm going to do 2 decimals on this one, just to be a little bit more accurate. Now, if I wanted to, I could use the Pythagorean theorem, and I could figure out that this leg is also 24. I don't have to do that. All right? I could look at angle A and say, based off of angle A, the information I was given would lead me to use that the sine of A is the 7 over 25. And I can use that exact same ratio to figure out that other angle. All right, but again, you're going to have to go into your calculator and figure out what is the sine inverse of that ratio. And if you do it right, you should get somewhere around 26 or so degrees, because angle A and C have to add up to be the other, like 90. And so I'm going to check that really quick. or sorry, 16. I said 26. It should be 16. Yeah, 16, 20, or 73. Yep, that's 90. And so, I mean, like I said, if I wanted to find the other side, I could. So I could use tangent at some point. But if you don't want to find that other side, you just have to like know which of the trig functions you're working with.